Welcome back to our lesson practice review, where today we are going through our chapter 2, lesson 3 practice. To start, we're going to summarize what we did in lesson 3, which was really focused on the identities of how we can use them to factor or rewrite expressions in factored form. Specifically, we're kind of looking at these two ideas here where we have talked about to be able to take something that's a trinomial here, 3 terms, and break it into binomials that are being multiplied together. And so we're going to get some practice with those to see how those work. For number 1, which expression is equivalent to x squared plus 2xy plus y squared? And when we're doing this problem here, really the main focus here is to see what multiplies out, because when we get more practice, we'll recognize the identity automatically. If I were to go through and see here, I know personally that this first one is not going to work because it is what we call conjugates, where when we use the box here to multiply, the middle two terms here cancel out. Xy plus a negative xy becomes just 0, giving me x squared minus y squared, which is not really what we're looking for here. The other thing to recognize is that there's only addition signs in the expression we're looking at. So really there's not going to be any negative signs that we deal with. And so I could go through each of these and multiply them out to see what we get. But just to kind of start here, if I was to multiply these out, 2x plus 2y times 2x plus 2y, 2x times 2x is 4x squared, which is already not my first term. So not going to be b. This subtraction sign, again, is going to throw things off. So I know my answer is going to be D, but just to prove it and to show, if I were to multiply this out, x times y, and then I get y squared. And then when I add everything together, I get x squared plus 2xy, because there's two of them, plus y squared, which is what we originally started with. For number 2, it asks us to select all the expressions that are equivalent to 8x squared minus 40x plus 50. The first thing I'm going to do here, it kind of tells us, because it's a multiple choice problem, our first step here is to use what we know about greatest common factors to pull out a 2. And so what that means is I'm going to take each of these terms here, divide each of them by 2. So this becomes 4x squared. This becomes negative 20x, and this becomes plus 25. And that's factoring out, the opposite of the distributive property when we multiply things in. So in this case here, we end up getting 2 times 4x squared minus 20x plus 25, which is A. The next thing here is I'm going to factor this. So I'm going to look at this and use my box. First term here is 4x squared. Last box is 25, and then I am going to try and figure out what goes on the middle two boxes. We're breaking down negative 20x into two pieces. So multiplying 25 times 4x squared is just 100x squared. And what I end up getting here, what do we got? Is it negative 10 and negative 10? And let's see here, when I'm factoring out to deal with the box here, I always start with the top left one. I see that it's going to be 2x and 2x. And then negative 5 and negative 5, because that multiplies to positive 25 and gives us our negative 10x's in the middle there. So what we see is that this factors out into 2x minus 5 times itself, which is B. It does not come out with C. And since it is subtraction on both of them, I would say it's not D, but we can represent it the same way as E. Because I'm doing 2x5 times itself, I can just say 2x minus 5 squared. So our three answers here are A, B, and E. Problems number 3 and 4, we're filling in the blanks to make each equation true. So this one's a little bit tricky to kind of handle here, but again, I'm going to use this idea of the identities here. If I look back up at my green equation, where we took, this was x plus y times x plus y. And the last term here, y times y, becomes this last term here, which is y squared. So here I know that this has to be 5, because negative 5b times negative 5b becomes positive 25b squared. So that's where I got my first number from. The thing in the middle here, so I know that these two have to multiply by each other, like x times y, and then multiply that by 2 to get that middle term. So in this one here, it needs to multiply to negative 30. If I were to divide that by 2, that would be 15, and then 5 times 3 is 15. So again, that's because when I multiply this first term, 3a times 5b, that becomes 15ab, and then if I multiply that by 2, that gives me 30. And then that means that since my first term is 3a, 3a times 3a is 9a squared. So getting rid of all my arrows here to show us this final answer here. Again, we could double check this work by throwing it into the box and multiplying it out to see, 3a and negative 5b, 3a and negative 5b, 9a squared, negative 15ab, negative 15ab, and positive 25b squared. These add together to get negative 30ab, 9a squared minus 30ab plus 25b squared, which works out for number 3. Number 4 here, so to start, we can kind of see that these are addition and subtraction. So in this one here, I'm actually going to be thinking more along the lines of our difference of squares identity, where we have the same thing here. So 2x plus 3 and 2x minus 3, because when I multiply, let's do this in a different color actually. If we were to keep them the same, 2x plus 3 and 2x minus 3. When we put this into the box, what ends up happening here is we get this 4x squared to start, then we get positive 6x, then we get negative 6x. So these two here are going to end up canceling out and give me minus 9 at the end. So this becomes 4x squared minus 9. Oh, and this looks like it says a little squared here. So instead of saying 4x squared, I'm actually going to say a 3 here because it's 4x squared minus 3 squared. And that should wrap up for 3 and 4. Problems 5 through 7. Here's a partially filled in diagram. Which expression does the diagram represent? So for the first one, I can see that the outside I'm multiplying x plus y times x plus y, which if I multiply something by itself, another way to rewrite that is to square it. So I would say that a is the expression that we're trying to multiply here. For number 6, we are completing the diagram. So I'm actually going to go through and do this one here. X times x is x squared. Looks familiar, problem that we did for number 1. And then for number 7, write an identity using the expression. So our identity here could be a couple different things. I'll say x plus y times x plus y, which is equal to x plus y squared. We know that that is equal to what's inside the box, which is x squared plus xy plus xy plus y squared, which to finish that off in our identity, we'd get x squared plus 2xy plus y squared. So again, that's all of the steps here. If I was going to kind of simplify that, maybe what we would see is if I am squaring a binomial that is being added, then I get a trinomial where it's the first term squared plus the two terms multiplied by 2 plus the last term squared. And that would be kind of my identity that we're talking about. Now onto our spiral review, problems 8 through 10. Here's the equation of a parabola, and we are asked to first determine the vertex of the parabola. Luckily, this one's already in vertex form. So when I'm doing this one, I can kind of tell that my x value of my vertex is going to be positive 1 because it's always the opposite sign of what's in here. This is, again, kind of what I'm going to call our h value, which represents the x value of our vertex. And then our k value here is the number being added on the outside, which we keep that sign the same, and we call the vertex at positive 1, positive 9. Number 9, rewrite the equation in standard form. So to do that, pretty straightforward here. We're starting off with y equals x minus 1 squared plus 9. And to put it into standard form, I'm actually going to expand this. I'm going to multiply x minus 1 times x minus 1. And we're going to get x squared minus x plus 1. So what this becomes is y equals x squared minus 2x plus 1. This ends up being one of our identities where we're squaring this here. The only difference here is that when you multiply this x and 1, you'll also have to multiply the negative, right? So x times negative 1, and then multiply that by 2. And then we have to make sure to keep our 9 in our equation. So when we are going to finally write this equation, I guess I'll do it up where it asks me to, up here. We got y equals x squared minus 2x plus 1 plus 9, which combines to be plus 10. So then the last thing that it asks us is, hey, what is the y-intercept? Well, in standard form, it's really easy because to find a y-intercept, we just plug in x equals 0, which makes this 0 because it's 0 squared, minus 2 times 0, which is just 0, plus 10. So our y-intercept here is just going to be 0, and then whatever this last number is in standard form. And that'll do it to wrap up lesson 3 from chapter 2. Next up, we got 2.04 in our lesson practice videos.